Okay, well, I realized I forgot to do an example with a negative a, so let's do that. So what we're going to do is start with the function not in standard form, and we're going to do two problems. One where the coefficient is -1 and one where it isn't -1. So let's do plus 6x, and trying to think how I want this to do. I want to make sure that it's something that has some x-intercepts. So what I'm going to do is I'm going to plot the function so I have something that works. So we have -x squared plus 6x. Let's plug that in. -x squared plus 6x. Graph that. Okay, well that does have a x-intercept, so that's good. So let's use that one. Well, no, let's add something or subtract a few from it. Let's say -3. Okay, so there we still have x-intercepts, and it looks like we have integers for the vertex, so that's good. So -3. Okay, so when you have a negative coefficient, what you do is you're going to factor out the negative sign out of the first two terms. So you'll have x squared minus 6x, and then we're going to leave a space. So here you got -1 times x squared gives you -x squared. -1 times -6 gives you positive x. And then you put this other term outside. You don't do anything with that third term. Okay, then we're going to do completing the square inside the parenthesis. So you take -6 divided by 2, and you square it, which is going to be -3 quantity squared, which is going to be plus 9. So we add 9 inside the parentheses, but we've got this negative sign, so we're really subtracting 9, so we have to add 9 to balance that. So we add 9 inside the parentheses, but we multiply it by -1, gives us -9, so we have to add 9. So then we can complete the square inside the parentheses. We take this number, -3, close parentheses, square. We add these two numbers together, which is plus 6. So now we're in standard form. So what we can say is that the vertex is going to be 3, 6, because remember we have x minus h. So the vertexes that our axis of symmetry is the line x equals 3. We use the x coordinate of the vertex. Our y-intercept is going to be equal to y equals 3, but we put it as a coordinate pair, so it's going to be 0, -3. That's because we set x equal to 0, and that drops the first two terms out of the equation before we put it in standard form. And then the x-intercepts, we take the equation in standard form and set it equal to 0. So we subtract 6 from both sides. And you might say, oh, I got a negative number here, but we still have a negative number on the right-hand side. So when you multiply both sides by -1, you'll get 6. So we can now take the square root. So you get plus or minus the square root of 6 is equal to x minus 3. Add 3 to both sides, so you get the x-intercept is 3, positive 3, plus or minus the square root of 6. So let's see what the decimal equivalent, so we can plot those on a graph. So you got 3 plus the square root of 6. So you get 5.45, and with the negative, so you get 3 minus the square root of 3, which is going to be equal to 1.27. So I think we got everything we need. So we'll add a page. We'll get a piece of graph paper. Everything's going to fit okay. Accidentally put a little dot there. Get rid of that. Okay, so we're going to label the X and Y axes. So each grid mark stands for 1 unit. So our X-axis is our Y-axis. So let's go down. Vertex 1, 2, 3. So it's 1, 2, 3, 1, 2, 3, 4, 5, 6. So that is the vertex. 3, 6. Our axis of symmetry is the line x equals 3. That's our symmetry line. Then we have our y-intercept, which is 0, negative 3. So that is right here. Our x-intercepts are 1.27. So that's 1.27 and 5.45. So 1, 2, 3, 4, 5.45. The reason I'm pausing here is this is symmetric around the line x equals 3, so there should be the same distance between these two. And it doesn't seem to be, so we're going to stop here and do our calculation again. Oh, because I did one I'm wrong, that's why. So let's fix it. This one's the one that's wrong. Because the square root of 6, I did the square root of 3. So I get 3 minus the square root of 6. Okay, so this second point should be 0.55. So let's erase that dot that we put in earlier. So 0.55 is about here. And then we got 5.45. So you notice how these are symmetric around x equals 3. So it's 3, 4, 5, 5.45. And we can draw the symmetric point here. So we go 1, 2, 3 to the left, 1, 2, 3 to the right. So now we've got all the points we need. Okay, so that is our parabola. You can see it's pointing downward. We could draw the points. Let me just get a different color here. It is a parabola with a coefficient of 1 somewhere up here. Yeah, right here, it's coefficient of -1. So there are other points. You could go left to right and down 1. You could go left to right 2, 1, 2, 3, 1, 2, 1, 2, 3, 4. So that would give you another point. To the right 2, down 4, 1, 2, 3, 4. So that would give you that point. You could do it for 3, 1, 2, 3, and down 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's that intercept. Okay. Okay, so that's that one. I'm going to do one more, which has we're going to end up with an A that is different than 1, but it's going to be negative. So we'll get y is equal to -3x squared. This is going to be a little difficult because we're going to put some fractions in here as well, I think. So let's do that. Plus 8x. So let's go ahead and plot that, and then we'll choose the third number to make sure this thing has some x-intercepts. It doesn't have to always have x-intercepts, but negative 3x squared plus 8x. Okay. Negative 3x squared plus 8x. Okay, so graph that. So there it is. And oh yeah, that's going to have a 0, 0 coordinate. We want to make sure it's not that, just to make it a little more exciting. So let's add 2 to the whole thing. Okay, so there we go. That's the function I have. So I'm going to add 2 now. Okay, so the first thing you're going to do is you're going to factor out the negative 3. So you get negative 3 times x squared. And when you factor out negative 3, that's the same as dividing by everything by negative 3. So that's going to become negative 8 thirds x. Leave space, add 2. So I'm leaving the 2 outside. Now you can check it all out by going back one step. So negative 3 times x squared is negative 3x squared. Negative 3 times negative 8 thirds is going to be positive 8. So we're good. Okay, now this is where it gets a little exciting. We're going to take the coefficient, negative 8 thirds, and we're going to divide by 2, and we're going to square it. So you can see that what's going to happen is that I'm going to divide the 8 by 2. Let me just show you how that works. So if you have negative 8 thirds, if you divide by 2, it's the same as multiplying by the reciprocal. So you get negative 8 thirds times a half, but you can simplify this down to 4. So it becomes negative 4 thirds quantity squared. So negative 4 thirds squared is positive 16 ninths. So that's what I'm going to add in here, plus 16 ninths. Let's make sure we did that right. 4 thirds squared is 16 ninths. Now, so I've added 16 ninths in there, but what I've really done is I've subtracted negative 3 times 16 ninths. So let's do that. So we can simplify that. It's going to be negative 16. Okay, so negative 3 times positive 16 ninths. Oh, I just realized that. 16 ninths. Glad I checked that because I would have gotten that wrong. You still can simplify it, but it's not going to simplify quite that far. So these are going to cancel out, and you'll get negative 16 thirds. So 3 over 9 is 1/3. So that's equivalent to what I'm doing. So I have to add back in 16 thirds to balance out what I just did there. So the first part, you're going to have negative 3. This is, you can make this into a complete square, and what we do is we use this number after we've simplified this expression. Before we square it, but after we simplified it. So it's going to be x minus 4 thirds quantity squared. And then we got this additional part, which we want to combine together. So 2 is going to be 6 thirds. Take 2 times 3, you get 6. 6 over 3 is 2. So you add these two together, because they have a common denominator, you're going to get plus 22 thirds. So that it is, there it is, it's in standard form. So what can we say about this? We can say the vertex is 4/3, comma, 22/3. This is a 1.3, and this is going to be 7.3. So if you plug that into your calculator, you get 1 1/3. This is 7 1/3. So before we do anything else, let's just check our graph and make sure we didn't make any mistakes. So I'm going to make this smaller so I can see it. So what it is this vertex, and if I bring my cursor up to the vertex, it says x equals 1.26. That's because I'm not quite at the vertex. And y equals 7.3. Close. Okay, so that's close enough for government work because I'm just using my cursor to check things out. So that looks good. Okay, so that's our vertex. Our axis of symmetry would be x equals 1.3. Just take the x coordinate. Then we got the y-intercept. That's actually the easiest thing here because the x-intercept is just the coefficient here in the original equation. So it's going to be 0, 2. So we set x equal to 0. We get 2. Let's go back to the graph. So here you go. You can see the x-intercept. Let's zoom in a little bit in the x direction. So there's your y-intercept. Okay. Next thing, we need to find the x-intercepts. So you take the equation in standard form. Set it equal to 0. Okay, so this comes to the other side. It becomes negative 22/3 is equal to negative 3 times x minus 4/3 quantity squared. We divide by 3, negative 3, so that'll become positive. So you get 22 divided by 3 divided by another 3. So that's going to be 9. 22/9 is equal to x minus 4/3 quantity squared. So we take the square root, so we get plus or minus the square root of 22/9 is equal to x minus 4/3. And if you add 4/3 to both sides, you'll get 4/3 plus or minus the square root of 29, or 22/9. I could simplify that down because the square root of 9 is 3, so you get 4/3 plus or minus the square root of 22/3. So I'll plug that into our calculator. So you get 4 divided by 3 plus the square root of 22 divided by 3. So that's one of the x-intercepts is 2.89 or 2.89, 0. And the other x-intercept is changing that to negative the square root. So you get negative 0.23 or negative 0.23, 0. So let's pull the graph up and look at those 2 points. So here are the 2 points. If I take my cursor and look for where it crosses the x-axis, you'll see it's negative 0.2 something. And it's positive 2.89. Now you can always zoom in. If you zoom in on this, you can get a much more accurate answer. This is negative 0.23. So that's that one. And if I did it zoomed in on the other x-intercept, I would get 0.28966. Okay. So that is the graph. Now if I didn't have the graph plotted already, I'd take a piece of graph paper I would draw this thing. So what you would do is you would label your graph. You would find the vertex, which I think I've done somewhere here. Well, the vertex is 4/3, that's 1 1/3, 22 thirds, which is 7 1/3. 1, 2, 3, 4, 5, 6, 7 1/3. So we're about there. That's your vertex. You have a axis of symmetry right there. Your y-intercept somewhere here was, what was the y-intercept? It was 2. So you go over here and put a dot right there for 2. There's your vertex. You could also draw this symmetry. So this is 1.3. If you go 1.3 again on this side, draw a dot. And then you have your two x-intercepts, which are negative 0.23 and positive 2.89. 2.89, like there. And so then you could draw this thing as such. So that's kind of not a great sketch, but it's the same idea. So this was, it had a lot of elements that just made it so you had to be a little more careful. But we factored out the coefficient in front of the x squared, which was negative in this case. So we had to change the sign of the second term. You still take the middle, the term associated with the x after you factored out the coefficient in front of a. You divide it by 2, simplify it, square it, add that inside the parentheses, but then you've got to subtract the appropriate expression, which in this case was negative 3 times this is what we're equivalently doing. So we had to do the opposite of that, which was adding 16 thirds. Combine these two into a single fraction, and then you ended up with the expression in standard form, which then allowed you to find the vertex HK, the line of symmetry, x equals h. Go back to the original equation to find the y-intercept, and then take the equation in standard form, set that equal to 0, solve for x. That gives you the x-intercepts, and then you can plot those. Plot your vertex, your y-intercept, the symmetric point associated with the y-intercept, the two x-intercepts. That gives you 5 points, and plenty to draw a reasonable curve.